Okay, so here is the setup that you guys will be using throughout the semester. All right, if I look carefully at this, you can see that what I have is this disc here that can rotate freely. That's connected to the actual drive motor. All right, so I'm going to come around to the back. All right, I can see that the drive motor is here in the back, and I can see leads connected here and here. Those are the actual leads that I drive on this machine. What I can see if I come around to the side here real quick is you can see that this motor is directly connected. Okay, there's a shaft that goes directly across through the middle of this thing. So a shaft going through the wall here, okay, through this wall, connected to this disc, but then also connected to this what we call tacho generator, a tachometer. Basically what it is a generator. It's being spun by the motor, and you get a voltage at these two terminals that's proportional to speed. Okay? So you'll see this, you guys generate, I give you measurements of what we call VTach, all right, the tachometer voltage. That's the voltage that's measured at these terminals. If I know the K motor constant of this particular motor, then I can say, I can relate this voltage using that K constant, K tach constant, to the actual speed of this shaft. And the important thing is, you can see if I go over here, you can see this orange thing here, okay? Basically what we see is that there's a belt drive, we call this, between the motor shaft and this sort of central piece right here. And then that is connected through another belt to what I call the secondary shaft, okay? And that secondary shaft, if I come around again to the side, you can see that there's a big fat pulley on this secondary shaft and a little tiny pulley on the central shaft. Okay? Now, if I run this thing, let me turn this on real quick. All right. First of all, the way I'm running this is I've got a power amplifier, which you guys will build later, all right, on this thing. And the power amplifier is getting a command from a function generator down here. So what I'm going to do is I'm going to turn on the power supply. All right, and I can see this thing moving. Now what I want to point out is because of the gear ratios here, because of the pulley ratios, notice that this guy over here is spinning pretty rapidly. So in other words, the actual DC motor, which is connected here, is spinning pretty rapidly. But notice that this guy is moving somewhat slower. And the reason he's moving somewhat slower is because of sort of the pulley ratios, right? They're all moving at different speeds because the size of these wheels on these belts is all different, right? If I knew the diameters of those pulleys, I could relate through the diameters of the pulleys how fast they're going, all right? As it turns out, you can see this right here. All right, it says output RPM is 1/32 of motor RPM. In other words, this guy here is moving 32 times slower than the motor is. And you'll see that in the data that you look at. So I'm gonna refer you to this video to see this. But the measurements of, so when you go to get K tach, right, you will be looking at measurements of this voltage and measurements that we recorded of the speed using this digital readout. Now, because of the way that we recorded those measurements, let's stop this for a second. Because of the way that we recorded those measurements, so measuring this speed and the voltage here, what we ultimately want to find out is K tach. In other words, I want to know exactly what the K value is for this motor. So what I really need to know is the speed of this shaft and this voltage simultaneously. Okay? I can't measure that. In this case, what I can do is I can measure the speed of this shaft and I can measure this voltage. So I have to take into account this factor of 32. Okay? The other thing is, this guy told me the speed in revolutions per minute. So I have to convert that RPM value into a radians per second value. Okay? And again, let me just run that again real quick, right? And you can kind of see that on the screen. You can see this guy moving pretty quickly, and this guy's moving pretty slowly. right? Effectively, this guy is moving 32 times faster than he is. So for every one rotation he makes, this guy makes 32. All right, now, a couple of other things we'll take a note of. This guy right here, which I can move down, is a brake. All right, a magnetic brake. That's basically a disturbance on the machine. All right, now some of you guys asked about this. Well, if I put a disturbance on the machine, it's supposed to draw more current. So let's take a look at that here real quick. Here's the current out of the power supply. All right, let me go ahead and lower the brake down. There's the brake. The machine stopped. The current went way up. It goes back down once I release that. All right, so the physics more or less work. Now we'll talk more about this later, but on the back of this thing, when I want to do position measurement, you can kind of see, again, let me turn this off. You can kind of see how this has angles here. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees. Eventually we're going to do a position controller, and we're going to tell this thing to go to a particular angle. Okay? Now when we do that, we'll need to measure position. And the way we will measure position, if I go to the back here, and you can kind of see this, this guy right here is a potentiometer. And that potentiometer has 3 leads on it. And we'll put a voltage on the potentiometer to be able to relate the position of this wheel to a voltage. Okay? All right, so I think that will familiarize you a little bit with what's going on. Okay? This guy is, and we'll have 3 measurements that you'll be looking at. The VTach, so the voltage coming out of this tachometer, the voltage that we apply to the motor leads here, okay, so the voltage that actually gets applied to the motor, and then we also measure the current going into the motor, and the way that I measure that is using this current gun right here. In other words, I basically put this on the leads of the motor. So the leads of the motor actually come up here, and you see that they're detachable, so you guys will actually be able to use this later. I can slide this gun basically around that wire to be able to get a reliable measurement. Now I tell you to scale the values by a particular constant when you do the work inside the lab. And what you'll see is basically this. This guy gives me an output voltage, and I have this set to a particular gain factor. 100 millivolts per amp. So in other words, what that means is if 1 amp is flowing through this window, so there's a wire that goes through that window. If 1 amp flows through that thing, this guy gives me 100 millivolts of output onto the oscilloscope. So that means I need to scale whatever measurement I have on the oscilloscope. And in the data files you have, I need to scale it by this factor, 100 millivolts per amp, to be able to figure out how many amps I actually had. All right, so you guys have a little bit of work to do, but hopefully that helps to describe the way this overall system is sort of functioning and what its capabilities are.